Technogenesis is a program at the Stevens Institute of Technology in which students, faculty, and colleagues in industry contribute to the process of conception, design, and marketplace realization of new technologies. Students learn how to transfer an idea from the conceptual stage and put it into play to solve the world's greatest challenges. While most science and engineering schools emphasize research and education, Stevens places equal weight on entrepreneurship. The program is primarily designed to reinforce the links between research, technology, and commerce. The process involves taking research and overlaying aspects of entrepreneurship and commercial value. The projects that students worked on in 2010 were numerous.
Research and data mining.
Measure shear stress in the cortical bone.
The nuclear pore complex.
Wisdom of crowd methodology using a stock market mechanism.
All-encompassing audio engineering suite.
Small-scale cancer research.
Bone tissue engineering.
Making graphene.
Robotic surgery.
Technogenesis has behind it a philosophy of academic entrepreneurship. In our innovative environment of invention and applied research, students work together with faculty and government agencies or private sector investors to develop new technologies and successfully bring them to marketplace.
So our project is to design a device that will measure shear stress in the cortical bone on the pedicle, which is a bone in the spinal column, which will measure the shear stress and eventually be able to prevent cracks in bones. It'll be able to monitor the stress that will let surgeons manipulate the way they insert pedicle screws, which will prevent cracks.
Ultimately, we will be using this concept for our own device in which a surgeon can use it to clip onto a bone during surgery. So as the bone is expanding, he can know, kind of like a warning, this is too much, the bone is going to crack, so stop the procedure.
First, we created prototypes out of cardboard and then out of the brass, which would be the final material we would use, and then to mount the strain gauges and then to solder on the wire, which would eventually be plugged into a processor which would read out the strain.
Students involved in the program engage in research, innovative design, or business projects. The Technogenesis approach showcases how to address the many challenges in commercializing university-generated technology.
We're working on, right now, selling in a commercial market software as a service. Our product is IDA Systems, and right now we're talking to several clients trying to pitch this software solution and get demos.
We basically go on the phone. We have these two lists, the IRI and FEI lists, which are two conferences that we attended, and we basically go on the phone and try to get in touch with them and say, look, this is who we are, this is what we do, are you interested in a demo?
It's an ideation management tool that companies can employ to either get the next big idea from their employees, their customers, or suppliers, or they can use it for the day-to-day smaller ideas that'll help them shape the way they do business and stuff like that. Because it uses the wisdom of crowds methodology using a stock market mechanism.
The program is primarily designed to reinforce the links between research, technology, and commerce. The process involves taking research and overlaying aspects of entrepreneurship and commercial value.
In this lab, we're studying the nuclear pore complex. One of the most important parts of the work is cell culture. So we're growing the cells, maintaining the cells, and then we'll harvest them and then use for experiments. And so the experiments include Western blotting, electrophoresis, immunoprecipitations, and all of these methods are ways to isolate the proteins of this complex and then try and detect what we have in what fractions. Mutations that may occur in the proteins that make up this complex are known to be associated with lots of diseases, leukemias, premature aging disorders, and so antibodies that we're using to detect these proteins, they can be envisioned as markers for disease, because mutations in these proteins would be what's causing diseases.
Students use state-of-the-art collaboration tools, receive extensive instruction, and work in small, cross-functional teams to create a business plan for a nascent startup company built on current university technology.
We're making an audio engineering suite for the iPhone, sort of a bunch of mini apps into this one all-encompassing app. And it's got some stuff in it like, you got reverb time, it's got a tuner and a decibel reader, a spectral analysis meter, and sort of a bunch of stuff that when anybody walks into a certain space, the idea was that we could develop an app that would allow you to get a better feel acoustically for that space.
I'm putting together the back end of the application dealing with the audio cues and audio buffers and the pulse code modulation files and converting that into the values that we need to represent the data in our application.
Technogenesis is about not only encouraging traditional research, but also promoting the stages beyond scholarly publication of the results, to include the establishment of intellectual property and the transition into commercial realization.
My Technogenesis project revolves around robotic surgery. We are trying to engineer a more cost-effective way to perform surgery on humans using more precise technology than just a surgeon's hands, trying to bring an interface between a surgeon and a patient to give that extra edge needed to perform that really complicated nerve bundling surgery, or just a more efficient way to do a common prostatectomy.
These are actually gaming controllers that we thought would be really useful for giving the surgeon a more tactile feedback. The idea is it'll be as if he's just holding a scalpel, and then the robot receives feedback and in real time transmits that to the device, and then the surgeon is able to feel what is going on inside.
The skill sets developed become an important asset for graduates, whether at the bachelor's, master's, or PhD level.
I'm working on making graphene. It's officially called heat and pressure assisted deposition of graphene on substrate or silicon oxide wafers. You put graphite on a piece of tape and peel it off, then you rub it together for 2 to 3 minutes. Then you put another piece of tape on it, peel that off, that's called exfoliating. Then you put your substrate, which is the silicon oxide wafer, on that and rub it together for 5 to 10 minutes. And then you use the microscope here and search it. It takes about an hour to search the whole sample and see if you found anything. And it can be used for different things like touchscreen. They want it to replace silicon. It's transparent and flexible, so they want to make flexible electronics with it. Yeah, things like that.
For Stevens students, the experience is an unparalleled opportunity to take up intellectual and professional challenges while boosting their chances of achieving the next step along their career paths.
What we did was go around to all these different colleges and universities and interviewed the Veterans Service representative there, see what they're doing right, see how maybe some of their programs could fit into the Stevens program. Also take away any concerns or issues that came out of the veteran student body there. It also involved communication with the Department of Veterans Affairs, seeing what the educational institution can do on their side to make the VA's job a bit easier.
Stevens demonstrates its commitment through the development of several startup companies, increased patent activity, and the incorporation of Technogenesis philosophies, concepts, and techniques in the classroom.
My Technogenesis project is bone tissue engineering. So in this case, we're trying to work with cortical bone. We had to make the extracellular matrix. So there is a couple of different methods that we tried out, and right now it seems to be pretty good, and we're sticking with one of them that involves hydrogel. So the goal for this development is so that we can actually put in like a partially biological like implant to the person that will help healing, and then eventually they can grow their own leg or arm back, and that's the idea.
Now in its 15th year, the Technogenesis program has successfully bridged university research and education with commercial enterprise development.
In my Technogenesis project, I do like small-scale cancer research. It's like specifically like cell matrix interactions. It's like a cellular scaffold, and it provides structural support and anchors a cell. And more importantly, it's like a signaling molecule that it communicates with the cell's nucleus, causes nuclear changes, like nuclear structure changes, and then leads to specific gene expressions. I can also study like inhibitors that prevent nanofiber-based cell migration, and that would develop like a nanostructure therapeutic reagent that would help, maintain cancer, like attack the cell migratory proteins and maintain cancer in a specific area, because metastasis is like a big issue when cancer cells spread.
The program gives students a leg up in their search for jobs, admission to grad school, and research positions.
Technogenesis, it was a great opportunity. It was really nice to know a hands-on experience of research and what real research and industry entails.
I love the program. It's amazing. I would never have gotten the opportunity to do all the work that I'm doing without this program. I've learned so many different procedures.
I think it's a great way for engineering students like me to get a leg up when we're trying to enter the job market.
You get to pick your project and you get to pick like what you want to do and what you want to work with, and it's a great opportunity to learn things that you cannot learn in the classroom.
The Technogenesis program has created a culture of innovation at Stevens that has developed products and enterprises for the advancement of society. For more information, please visit our website at www.stevens.edu.